Hey everybody. We have adding and subtracting rational expressions with unlike denominators this time. So I'm just going to do it with regular numbers first. I'm going to show it a little bit differently than you probably learned it in elementary school. And it's going to help us a lot this new way. So I sort of started by writing some down so the video would go a little faster. So we have 1/6 plus 3/10. I wanted to, instead of just figuring out what they both multiply into by looking at numbers, I wanted to break it down to what makes up both of these things. So 6 is made up by 2 and 3, 10 is made up by 2 and 5. They both have a 2 in it, but the other number is different. So you gotta think like a little kid, like a 2-year-old. They're so jealous of anything they don't have, right? So like if this 6, this 2 times 3 is one kid, he has a 2 and a 3. Those are like his toys. Does he want another 2? No. He's in fact probably not even interested in his own because he's already got one and the other guy's already got one. But he likes having the 3. But guess what he doesn't have? He doesn't have kid 2's, this 10. He doesn't have kid 2's 5. So this guy here, he wants a 5. And this guy over here, he wants the 3. Because that's what he doesn't have. So what we're going to do is we're going to give him it. So we have the 1/6 and the 3/10. So we saw that the 10 wanted a 3. Remember I underlined it in red, so I'll give him a 3. We give it to him with a 1 fraction. Because you're always allowed to times something by 1. I mean, multiply something by 1. It's just itself again. I'm not actually changing the numbers, so I'm not doing anything crazy to my math. The 5 is orange, so this side we're going to give a 5. And by doing this, we have a situation where we get common denominators, because now they're both the same. If you give them each what they don't have, then they'll all have the same things. They'll be the same denominator. So this here we got 5 over 30, and over here we got 9 over 30. And we can just follow through with our same procedure we learned in the last video. 5 plus 9 is 14. And then the denominator is the same, so we got 30. So, wow, that's an ugly 9. Here we go. So it's pretty similar, but you just have to make sure you be a terrible parent and cave into the jealous kids and give them everything they want. We're basically trying to spoil both kids. That way they'll be the same. So, if stuff is factored, I'm going to give you 2 examples, a factored one and an unfactored one. Which, they're pretty much the same, just the unfactored one. You got to factor first. Anyway, so this is one I made up. It's factored. We have something they both share. So they're not interested in that, but what are they jealous of? This side over here, he doesn't have the 2k minus 5. So we're actually going to give him 2k minus 5. And we're going to give it to him as a 1 fraction. Again, sorry my handwriting. Drawing with a mouse is harder than it seems. We're going to give it to him as a 1 fraction. This side over here, he's jealous of the 9 plus k. So we're going to give him the 9 plus k because we're terrible parents. We're just caving to whatever the children want. And then we have to give it to him as a 1 fraction as well, because that way we're not actually changing the problem. We're just changing the way it looks. Okay, so this looks craziness, but it's actually not, because guess what we have now? We have common denominators. So I'm going to just write my denominator and then write the top. It's going to look ugly, but actually, I'm just going to write the denominator for now. We'll fill in the top as we go. So the denominator, notice each of them have the same stuff. They both have a 2k minus 5. Order doesn't matter with multiplication, so they both have a 9 plus k. And they both have the 3k plus 2, which they already shared. And guess what? Now we just have to do the top. So, in order to do the top stuff, we have to do a little bit of cleanup. We have a little multiplication problem here and a little multiplication problem here. So we're going to use our distributive property. 6 times negative 5 is negative 30. Again, the order doesn't matter as long as you're using the proper signs. So as long as you see that minus applies to the 5. 6 times 2k is 12k. My favorite way here is to think of this negative as with the 2k and just distribute. So you can do the 2k first and then minus the whole group in parentheses, but that just gets weirder. So I'm thinking of negative 2k times both of those. So we got negative 18k squared. Sorry, 2k squared. Negative 2k times k is negative 2k to the third. And now we have a bunch of stuff on the top. You want to see if you can combine like terms. So we're going to look for similar powers. Lucky for us, there's actually none, so we don't have to write anymore, which is cool. But if there were like terms, you'd have to combine them. So we are officially good to go. We could show one where we need a factor. So if you have stuff that's not factored, it's really hard to see what they need. Like, you're just going to think that, oh yeah, you need the whole thing, and oh yeah, you need the whole thing. That may not be true. So, but if you factor, then you actually might be able to have some part that is shared, so you don't have to give them so much. You're not doing so much math. So let's factor this and see what we got. So we got 5x over, and then we got 13 over. So we're going to factor the denominators. This looks like it's a common factor of 3. 3 divides both, and there's an x that divides both. So 3x. And then, so 3x squared divided by 3x. That gets rid of 3 and gets rid of one of them, so there's just one left over. 6x divided by 3x. So the x's divide to 1 and go away. 6 divided by 3 is 2. This side is the AC factoring. Luckily, A is 1, so we can do a shortcut. We still have to figure out what AC is. So AC is 4, and B is 4. So two numbers that multiply to AC and add to B. Hopefully you see it, but 2 and 2. 2 times 2 is 4. 2 plus 2 is 4. So we can write that in. And hey, guess what? They share something now. This is what we like. So it's not that bad if you have to factor it. Like, this problem is essentially, it's almost easier than this one because it's not negative sign. Negative is easy to mess up. This problem, though, kind of nice. They share the x plus 2. This guy has 2 of them, though, so, this kid's still jealous. This guy's 3 and an x. And we'll use orange. This guy's an x plus 2. So we're going to give kid 2 x plus 2. Because that's what he wants. That's what he's missing. And we're just going to cave. We're going to give the other guy 3x. Because he wants both the 3 and the x. And we're going to give it to him as a 1 fraction. Now I have a common denominator. They have the same stuff. 3x, x plus 2, x plus 2. Sweet. Just got to put all that at the denominator. 3x. And then, since it's doubled, I'm going to write it as x plus 2 squared, which literally means, times itself. So, something times itself. The top side, 3 times 5 is 15. X times x is x squared. This side, we're going to have to do a little distributing. I should use a different color, but whatever. So we got a plus 13x plus 26. And again, I'm going to have to look for like terms. Do they have any same power, same variable? Well, they have the same variable, but not the same power. So these are not like terms. And we are set, which is awesome. So that's the basic process. Talk to me in my office hours if you need. I'm Love answering questions. I got this fancy little whiteboard app that I can use. Check it out. Whiteboard. I could just draw on it and help you guys with anything. And we can just pull up Teams and I can share the screen. So it'll work great. I hope to see you all soon. And you guys are going to crush this. Let me know if you have questions.